This is our 10th lecture of class 12 maths. Today our topic is application of square matrices. You already learned in previous classes matrix being mainly two types, rectangular and square matrix. In rectangular matrix, row and column are not equal. If row and column are equal, that will be a square matrix. Two matrices be any order, be same order, be that is called equal matrix that compare to each other. Operation of matrices. There are mainly two operations, addition and multiplication. If we have two matrices of same order, we can add both matrices. But in the case of multiplication, column of the first is equal to row of the second matrices. In the case of transpose of matrix, row changes into column and column comes on the row. After this, we learn the determinant. Determinant is the acquired a number of the square matrices. It can be found by help of cofactor. In previous class, already we find a cofactors of different elements. Determinant, you multiply the different elements of the square matrix to its cofactor. Any row, you take any row or columns, you find the determinant of the square matrices. After this, we learn about the adjoint of a square matrix. Adjoint of a square matrix, that is a square matrices of cofactors. We find the cofactor of all elements of the square matrix, then transpose it. We find a square matrices that is called adjoint of a square matrix. Now, you can find the inverse of a square matrix by help of adjoint of matrix and determinant. In previous class, these are the processing of the we learned in previous class. Now on last we learn about the application. We can solve the system of linear equation by help of these. Now you have given one of the equation, you have given three equations, have three variables x, y, z, these three variables. If two variables, that is necessary to only two equations. These are three equations having three variables. Now first you prepare square matrices. The coefficient of variable we arrange in a square matrices 2, -3, 5. You arrange first row. 3, 2, -4 in second row. 1, 1, -2 in third row. Now, second matrices, this is column matrix, that will be only constant 11, -5, -3. X is the variables x, y, z. These problems, these equations have three variables, so you take the x, y, z. Now, according to previous rule, to find the determinant A, your first elements and cofactor of this cofactor of this, that means you deleting the row and column of these elements, and you have 2, 1, minus 4, minus 2. Second position is odd position, so you write the minus 3, and taking the elements, deleting the column and row. 3, 1, 4, minus 4, minus 2, 3, minus 4, 1, minus 2. On last element, have deleting this row and this column, 3, 2, 1, 1. And after calculation, you find the result minus 1. That means determinant of this square matrices is minus 1. If that is not equal to 0, that means this equation, these exist. Determinant A, B exist. Now adjoint A. Adjoint A. In case to find the adjoint A, you find the cofactor of all the elements one by one. You take the first elements, then delete the row and column and find this 2, minus 4, 1, minus 2. Similarly, all the elements of the square matrices, you find the cofactor. Then it transpose 0 to 1 in the row, it change into column, minus 1, minus 9, minus 5, 2, 23, 30 in row, that change into column. Now you already know this equation in form of A, that means a square matrices, X means variable, that is equate the constant. If you multiply of the first and last, that is equate to this results. X equal to A inverse B, A inverse B. Now X, that means variable X, Y, Z. Adjoint, you find the inverse, A inverse by adjoint A by determinant A. This will be adjoint A that you find here. Adjoint A by determinant A. Determinant A, already you find the minus 1. And second thing, B constants, you write this and multiply both the matrices. You take the row and column of this, first row and first column, your result is minus 1. Second row and this column, your result is minus 2. Third row and column, your result is minus 3. You use the rule of multiplications. Now minus 1, divide all the elements of this matrices, you find minus 1 divided by minus 1, that is 1, 2 and 3. Now compare, these are equal matrices. Agar two matrices have same orders, be equate, then X, these are equal matrices, X equal to 1, Y equal to 2 and Z equal to 3. You can solve the any linear equations have two or more variables by these rule of matrices. Thank you.